Hey everybody, welcome to my YouTube channel. This is my very first video on this channel, and this could be the beginning of something great. Welcome to Tech Renaissance, where we will be talking about the latest and the greatest advancements and developments in the world of artificial intelligence, deep learning, machine learning, computer vision, virtual reality, and the related fields. My name is Malin Yogesh, and I'm an entrepreneur and AI consultant and host of this channel. In this video, we will talk about Mojo, a new programming language for AI developers. Mojo is developed by Modular, a company that provides a unified inference engine for AI industry frameworks and hardware. So currently I'm on Mojo website, Modular, where here it says Mojo combines the usability of Python with the performance of C, unlocking unparalleled programmability of AI hardware and extensibility of AI models. Now, with that being said, the real question is, what is Mojo? What is its potential? Will it replace Python? How fast is it compared to Python or other languages in performance? What differentiates Mojo from other programming languages that already work faster than Python? So let's go ahead and dive in. Mojo is a modern open source programming language created by Modular, a company that focuses on the development of modular and reusable software. Designed for simplicity, readability, and scalability, Mojo offers an excellent alternative for developers seeking a versatile and efficient language for building high-performance applications. And with that being said, don't forget to check out a couple of links and references that I have put in the description. First, let's talk about a couple of other projects. In the last couple of years, there has been numerous ongoing projects that try to make Python faster by focusing on different aspects such as just-in-time compilation, improved interpreters, and alternative implementations. One of them is Nutica. Nutica is a source-to-source compiler that compiles Python code into C++ code, which can then be compiled into an executable binary. This approach aims to improve the performance of Python programs by leveraging the optimization capabilities of C++ compilers. Nutica supports a wide range of Python versions from Python 2.6 to 3.9 and claims to be compatible with all Python code. Now, Nutica's performance improvements can be modest to significant depending on the nature of the code being compiled. For some workloads, Nutica might provide up to 2 to 3 times speed up, while for others, the improvements might be more modest. The performance gains generally come from reduced function call overhead and better inlining of the code. The next one is Numba, which is a just-in-time or JIT compiler for Python that specializes in speeding up numerical computations. It uses LLVM to compile a subset of Python code to machine code, focusing on NumPy array operations and functions that use NumPy arrays. Now, Numba can be used as a decorator on functions that require optimization, making it easy to integrate into existing Python projects. Numba's performance improvements mainly apply to numerical computations and array operations. When used appropriately, Numba can provide significant speedups in the range of 10 to 100 times faster for specific numerical operations. However, the actual improvement depends on the code being optimized and whether it falls within Numba's area of expertise. So as here you can see, it says parallelize your algorithms, simplified threading, SIMD vectorization, and GPU acceleration. You can go on the Numba website and learn about these. Numba is faster than Nutica, and it could be about 10 to 100 times faster than Python. Let's talk about the next one. Codon. So Codon is a high-performance computing library for Python that aims to speed up numeric computations. I'm currently on Codon. It focuses on providing a fast and efficient implementation of core numerical operations, such as matrix multiplication, linear algebra, and Fourier analysis. Codon makes use of optimized low-level libraries like BLAS, LAPACK, FFTW, which are written in C or Fortran to achieve high performance. Now, performance improvements with Codon depend on the nature of your code and the specific operations being performed. By leveraging the underlying low-level libraries, Codon can provide significant speedups compared to pure Python code, especially for compute-bound tasks involving large arrays or complex mathematical operations. The speed improvements can range from 2 to 10 times faster than Python, so that compares to Nutica. Again, you can read more about Codon in the Codon documentation and the GitHub. Let's talk about the next one, JAX, right? JAX, again, is a high-performance numerical computing library for Python. In the documentation, you can read about CPU, GPU, and TPU installation, a TPU tensor processing unit. You can just simply do a pip install. You can also read more documentation on JAX. And again, it's a Python library that combines the expressiveness of NumPy with the performance of hardware accelerators like GPUs and TPUs. JAX enables developers to write high-performance numerical code using familiar Python syntax while automatically optimizing the code for execution on specialized hardware. JAX uses just-in-time or JIT compilation, like some of the others that we talked about earlier, but JAX with XLA compiler to optimize and parallelize the code for execution on GPUs and TPUs, which can result in a substantial performance improvements. The performance of JAX compared to Python can be significantly faster, especially for numerical operations that can be parallelized and optimized for execution on GPUs and TPUs. So depending on the specific problem that you are trying to solve and the hardware being used, JAX can provide speedups ranging from 10 to 100 times or more compared to pure Python code. As you can see, you can read more about JAX in the documentation. We're just comparing some existing alternatives that make compilation faster than pure Python. And we also want to see where Mojo stands. The last and the final one we'll talk about is Julia. I'm in the Julia website as well, which has been linked in the description. You can download and we can read the documentation of Julia. I remember using Julia in my own PhD projects. I have used Julia for solving computational mathematics problems like nonlinear optimization, such as Newton and quasi-Newton methods, such as BFGS algorithm, trust region, SQP, and more. But from a programming language perspective, Julia is a high-level, high-performance programming language for technical computing that aims to combine the ease of use and expressiveness of languages like Python and the performance of low-level languages like C or Fortran. Performance improvements come from its just-in-time compiler, which compiles Julia code to native machine code using Turing runtime, enabling faster execution for many workloads. Additionally, Julia's type system and multiple dispatch mechanism enable the generation of highly efficient code, making it well suited for high-performance numerical computing. As here you can see different ecosystem and applications of Julia, including visualization, general purpose, data science, machine learning, scientific domains, and parallel computing. I had used Julia for computational mathematics, as I mentioned before. You can read about Julia in the documentation, the Julia website. Now, in the ones that we have just talked about, we've seen that these languages are anywhere between 2 times to 100 times faster than Python. I remember when Julia came out, everyone was talking about how it could replace Python. I remember even I thought that that might happen, maybe to a degree, but quickly I also realized that Python has the largest fan base and the largest number of libraries and packages available. The Python community is huge, and that is one primary reason that even when they outperform Python in certain areas, have not replaced Python so far. Now, where does Mojo stand compared to these programming languages when it comes to outdoing Python in performance? Modularity is at the heart of Mojo. The language is built around the idea of creating reusable and composable modules which can be easily integrated to form complex application. As I mentioned, Mojo is a statically typed language, meaning that the data types of variables are known at the compile time. This enables the compiler to detect type-related issues early in the development process, enhancing code safety and reducing the likelihood of runtime errors. In Mojo, immutability is the default behavior of the variables. So once value is assigned to a variable, it cannot be changed. This feature forces functional programming style, which can help minimize bugs and simplify the reasoning about code behavior. Also, Mojo treats functions as first-class citizens, allowing them to be assigned to variables passed as arguments and returned from other functions. This enables developers to write higher-order functions and create powerful abstractions. Mojo also has built-in support for concurrency, allowing developers to write efficient parallel code without the need for external libraries or frameworks. The language concurrency model is based on lightweight asynchronous tasks called fibers, which can be easily spawned and coordinated using channels and locks. Modular claims that Mojo utilizes the full power of hardware, including multiple cores, vector units, and exotic accelerator units, with the world's most advanced compiler and heterogeneous runtime. With Mojo, Modular cites that you can achieve performance on par with C++ and CUDA without the complexity. Mojo leverages MLIR, or multi-level intermediate representation, a compiler infrastructure developed by LLVM designed to optimize code for various hardware architectures and enable advanced code optimizations across different levels of abstraction. So here we are. Mojo outperforms PyPy, Scalar C++, and of course Python itself, claiming to be 35,000 times faster than Python. So if an execution takes about 1027 seconds on Python, it takes only 0.03 seconds on Mojo. Let's check out Mojo's performance dashboard. Let's select GPT-2 and we can see the speed of modular Mojo compared to Python and TensorFlow. Modular has a lower latency than TensorFlow and PyTorch, and has a much lower cost, significantly lower cost per 100,000 inferences compared to TensorFlow and PyTorch. Let's look at something in computer vision. Let's talk about CLEP-VIT large patch 14 and compare the cost of 100,000 inferences on Mojo versus PyTorch and TensorFlow. Real quick, what's CLEP-VIT large patch 14? Some of you probably never heard of that, right? CLIP is a contrastive language image pre-training, an AI model developed by OpenAI that learns to understand images and text by training on a large dataset of image-text pairs. VIT, or Vision Transformer, is an architecture that treats images as sequence of patches, similar to how transformers treat text as sequence of tokens. Instead of using convolutional layers like traditional CNNs or convolutional neural networks, the VIT architecture uses transformer layers to process and reason about these patches. I have attached a link to this article. It's very useful and descriptive if you want to learn more about vision transformers. Going back to the performance dashboard, now CLIP-VIT is the model that combines the CLIP pre-training technique with the VIT architecture for processing images. Large simply indicates that the model has a large configuration, which means it has more layers and high capacity and more parameters than a base small configuration. Patch 14 refers to the size of the patches that the input image is divided into. In this configuration, the input image is divided into non-overlapping patches of size 14 by 14 pixels. Okay, so let's go ahead and select a C5 4 extra large instance, which is an EC2 instance with a 32 gigs of memory and 16 vCPUs. And here the cost per 100,000 inference for TensorFlow is $7.64. For PyTorch is $5, and for modular it's $3.81. Similarly, you can check for other instances and you can do the cost comparison between Mojo and other Python deep learning libraries. The cost of running inferences on modular Mojo is pretty much half compared to TensorFlow and 70% compared to PyTorch, along with much faster speed. So because of this faster runtime and cheaper cost, I believe that Mojo has the potential to replace Python, especially since it has been much more faster than other counterparts that we have talked about earlier. However, we do have to remember that Python has the largest programming community along with the biggest collection of packages and libraries. So even if Mojo replaces Python, it may take a year or two for the popularity to grow. But we do have to be open to the possibilities and advance our skills by learning the latest and the greatest. And we definitely smell a great opportunity here. The earlier we start learning Mojo, the quickly we can catch up to the revolutionizing of AI and AI development. And with that being said, let's talk about how do you access Mojo. I'm here in the Mojo documentation, different examples and different Mojo modules. Also, Mojo is a superlative language over Python, so you can do a lot of Python programming in Mojo as well. However, Mojo is still a very young programming language and is still in work in progress, which makes learning Mojo a great opportunity. The Mojo standard library, compiler, and runtime are not available for local development yet, so they have created a hosted environment where you can try it out. It's called Mojo Playground, where you can play with Mojo using Jupyter Notebook. The Mojo Playground currently supports a limited number of people, but they plan to scale up so everybody can get access to Mojo over time. However, the earlier you apply, the earlier you can get access to Mojo. I just went ahead and applied last week. So if you go under Get Started, click on Sign Up to access Mojo Playground. It will take you to the simple form that you fill out and apply for Mojo access. When you receive access, you simply log into the Mojo Playground using the email address that you had used in the sign-in link. They also have a Discord channel and a GitHub where you can connect with community or report on issues or simply learn more about Mojo. The Discord channel is where they make regular announcements and you can meet the fast-growing Mojo community, other users, and latest development and how they're changing the AI world forever. Also, you can learn a ton of things from their GitHub repository, including the inspiration behind Mojo, the Mojo programming manual, the documentation, FAQs. So that's it for today's video. Guys, I hope it was helpful. Please like this video and subscribe to my channel for more content like this. I will create more videos on Mojo and the latest and greatest developments in the AI world and the tools that are useful in becoming more productive. I'll see you